Hello students, welcome again to the course of Advanced Machine Design. In previous lectures, we have discussed about the types of sections, and we have said that sections are the shapes which are used to build engineering structures. And we have seen symmetrical sections and unsymmetrical sections. Symmetrical sections are having axis of symmetry, either single axis symmetry or multiple axis symmetry or two axis symmetry. However, unsymmetrical sections don't have any axis of symmetry. In case of symmetrical section, we have also seen that we can use our simple bending theory to calculate the amount of stresses developed in the section, because in case of symmetrical sections, the bending moment is acting on the plane of the symmetry, and we can have the distribution of stresses and strains about the center point of the section using simple theory of bending or flexural stresses. In case of various type of sections, we have seen during the loading condition, when the load is coincident with the axis of symmetry, how the beam or the structure will behave. We have seen that whenever we will try to change the direction of loading other than the axis of symmetry, in addition to bending, there will be some amount of twisting present in the structure. We have also seen the second type of unsymmetrical bending, where the bending and twisting takes place, and due to the type of section which is unsymmetrical, but the loading is on uh, uh, the axis of the section. So both these factors produced bending and twisting in a unsymmetrical section. You can also visualize the type of unsymmetrical bending in case of C section. We have seen that to eliminate the twisting couple, we want that our system should behave in pure bending, and we don't want any type of twisting couple. So we want to eliminate the twisting couple by making all the forces in equilibrium, and the forces which are primarily involved in this process are the shear forces and shear couple which are produced due to the application of load W. So we want to equate the couple due to shearing forces and the couple due to external forces, so that these forces should be in equilibrium and there will be only bending and negligible or zero twisting. So it is said that the bending is symmetrical or pure bending if the product of inertia is zero about the two coordinate axes passing through the centroid. So when the axes are passing through the centroid, in case of symmetrical sections, the product of inertia of the section is zero, and due to this axes are called the principal axis of the section, and the product of inertia about these sections are zero, that is Ixy is equal to 0. And the product of inertia may be positive, negative or 0, depend upon the section and axis. If either one of the axes is axis of symmetry, then product of inertia is 0 with respect to the principal axis. So either two axes are principal axes, or one of the axes is the axis of symmetry, the product of inertia is 0, and we generally call it them principal axes. The product of inertia is given by the summation of x coordinate into y coordinate into the smallest area on this section. So in case of symmetrical sections, the axes are passing through the centroid and they are called the principal axes. So certainly if you look at the rectangular section we have considered, we can see that if we consider the width of this section is b and height of this section is h, so the moment of inertia of this section is bh cube by 12. However, the moment of inertia about y axis is hb cube by 12. So we can say that the maximum value of moment of inertia takes place around the x-x axis, and the minimum moment of inertia takes place around the y axis. Now, in case of unsymmetrical bending or unsymmetrical loading, we can see the load is applied at an angle to the principal axis or the axis of symmetry. Then the moment, which here is always showing a vector direction about x-x axis, it will also be act at an angle beta from the loading line or the line of action of the load, and this beta will be equal to theta because it is perpendicular to the loading line. So we can say that during the unsymmetrical loading, the load has some angle with the axis, and the resultant moment will also having some angle with the loading line. So if we talk about the shear center, why we need to use shear center? Because shear center is a point through which if we apply force, there will not be any twisting and only bending deformation will takes place. So shear, we want the shear center where we can apply load and we can control the twisting behavior of the structure, and we can have only pure bending deformation. For single axis symmetry, the shear center lies on the axis of symmetry, and for two axis symmetry, the shear center will lie on the centroid. For unsymmetrical sections such as angle and channel sections, stresses in each leg having set of forces should be in equilibrium with applied shear forces. So for unsymmetrical sections, the stresses in the different parts of that particular section should be in equilibrium with the applied shear force, so that we will have the shear center for that particular unsymmetrical section. So the summation of shear stresses over the section of the beam produced by a set of forces must be in equilibrium with the applied shear force. Means this the shear forces which are produced due to the application of force should be in equilibrium if the shear center should be lie on the centroid. In symmetrical sections, all the forces are balanced and shear center coincides with the centroid. So you see, if you are talking about a symmetrical sections, the shear center coincides with the centroid. However, in case of unsymmetrical sections or unsymmetrical loading, we have to calculate the value of E, which is giving us the location of the force which should be applied to make these forces or the couple produced due to these forces in equilibrium. So we can easily use this, our primary equation F1 into H equal to W into E, to calculate the shear center or location of shear center. E is equal to F1 into H by W. So this is a primary treatment for finding out the shear center in case of symmetrical sections. The more about this we will discuss in the next lecture. So thank you, students.